Hello and good day. Today in Geometry Gold, we're covering CO6, finding angle measures, setting up an equation to solve. Basically looking at the relationships that the different parts of an angle have, similar to what we did with segments. And we're going to start by defining a few terms, the first being angle bisector. What is an angle bisector? Okay. Angle bisector. Oftentimes in geometry, you can kind of figure out what the term means by looking at the word bisector. Right? Bi means two, sector means sections. Okay. So an angle bisector is a segment, ray, or line. Remember, that's my lazy abbreviation, SRL, for segment, ray, or line. That divides an angle into two equal sections. Okay? A segment, ray, or line that divides an angle into two equal sections. So if we had an angle that looks like this, our angle bisector would come from the vertex and come, that's not too bad, come straight out so that it divides the angle into two congruent or two equal sections. So that knowing that red segment there is an angle bisector, if I told you that this section was 20 degrees, you could then conclude that the other section is also 20 degrees, right? And the measure of the whole angle would be 40 degrees. Okay, so an angle bisector, it divides an angle into two equal sections. So if you know what one of those sections is, then you can find the other values of the angle. A linear pair. Linear pair. What is a linear pair? What does the word linear mean? Well, line. Okay, and a pair means two. So a linear pair would be two angles that form a line. A linear pair, two angles that form a line, and because they form a line, what do we know about the sum of their measures? Two angles that form a line. Here's an example. And because they form a line, angle 1 and angle 2 here, what do we know about their measures? Exactly. Okay, and the two angles will sum to 180 degrees. And finally, vertical angles. Have you heard of vertical angles before? Heard of them, okay. Vertical angles are angles that are opposite each other when segments, rays, or lines intersect. Angles that are opposite each other when segments, rays, or lines intersect. So an example of this would be if we have something, two segments that intersect. At that intersection point, we've got four angles that are created, right? Four angles there. Angles that are opposite each other, for example, angle 1 and angle 2, they're opposite. They have a relationship. Can you kind of, by looking at this diagram, guess what that relationship might be? Olivia? Yes. Okay. So vertical angles, and I'm going to abbreviate that VA. Vertical angles are congruent. So we could say that angle 1 is congruent. Remember, the congruent symbol is the equal sign with a little wavy thing over it. Angle 1 is congruent to angle 2. A second pair of vertical angles in this same diagram would be angle 3 and angle 4. They are also opposite each other. So we could say that angle 3 is congruent to angle 4. And just for kicks, what can we say about angles 1 and 3? What do angles 1 and 3 make? Audrey? Because they are a linear pair, right? Two angles that make that line, angles 1 and 3, we know their sum would be 180. So here's the cool thing, folks, is that if I tell you that angle 3 is 130 degrees, can you tell me angles 1, 4, and 2? Yeah. Angle 1 is going to be 50 because that's a linear pair. Angle 1 and angle 2 are congruent, so this will also be 50, which also adds to 180 with angle 3, right? Angles 2 and 3 also make a straight line. And then angle 4, which is vertical angle with angle 3, will be 130, which is also a linear pair with angle 2, so you have 180 there, and a linear pair with angle 1, so you have 180 there. Okay? So the relationships here are all over the place. Okay? So angle relationships are all over the place here. Okay? The angle addition postulate, if you recall that the segment addition postulate, that the sum of the parts will equal the whole. Okay? Same kind of thing here. We know that 20 plus 20 equals 40, which is the whole angle, because of the angle addition postulate. So the parts of an angle will sum to equal the whole angle. Just like the segment addition postulate, only now with angles. And then that next section on your page talks again, we saw this with segments also, about the difference between congruency and equality. Remember that when you say things are congruent, you are saying that they are the same. You aren't saying anything about value, okay? Just that angle 1 is the same as angle 2. Same size, same shape, whatever. When you assign value to it, once I said that angle 1 was equal to 50 degrees, now I can say that the measure of angle 1 is equal to the measure of angle 2. So when you use equality, it seems like a very small thing, but it comes up big when we get to proofs later on. But equality is used only when you have value. Otherwise, you're just saying this is the same as that. That's congruency. All right? This part here, you see that arc in between in angle A and in angle B, that is the symbol to say that two angles are congruent. Okay. In segments, we had that little tick mark thing. If we were saying that these two segments were congruent, we use that little tick mark there, right? With angles, we use the arc. The arc to mark. Okay. All right, so let's practice using some of these relationships here in these diagrams below. So it says, find the requested angle measure. Check your answer by verifying that the relationships work. So I'm asking you here for angle ABC, okay, which is this angle here in red, ABC, and also the measure of angle CBE. So from point C to point B, down to point E, this angle right here. So looking at the information that you've been provided, what is a relationship that we can set up? Lucas.
A, B, C, and D, B, and E are both have the same, are both congruent.
Okay, so we know that the measure of angle ABC is equal to the measure of angle DBE. Why? What tells us that? Audrey? Because they're vertical angles, and vertical angles are congruent. And the value that we've been given for ABC is 2x plus 7, and the value that we have for DBE is 4x minus 14. Lo and behold, we have an equation that we can now solve, right? 2x plus 7 equals 4x minus 14. This has variables on both sides. So if you remember variables on both sides, we got to put all of our variables on the same side. So you might start. Some people like to always keep their variable term positive. So they'd move the 2x, over to the right side here by subtracting 2x from both sides. Cancel that out. You have 7 equals 2x minus 14. Some folks like to move their x's always on the left side. It doesn't matter which side you put your variables on. No, it does not. All right. So no, it doesn't matter which side you move your x's to. If you prefer your x term always being positive, so you move it whichever direction you need that to happen, or if you always put your x on the left, it doesn't make a difference. What'd you get as a value for x? What did you come up with, Ellen? 10.5. Okay. See, that's why I still have a flip phone, because I don't understand technology. Okay, so 10.5 equals x. That's not our answer, though, right? Because the question was, find the measure of angle ABC and CBE. So it is what it is. If it happens again, I'll have students answer it or something. Okay, so if x equals 10.5 and ABC is 2x plus 7, we're going to replace x with 10.5. And that's going to give us the measure of angle ABC. So 2 times 10.5 is 21. 21 plus 7 gives us 28. And that would be the measure of ABC. Follow? Yeah. Okay. And so now how would we get the measure of DBE? Or sorry, CBE. CBE. Olivia.
You subtract 28 from 180.
Yes. And why is that?
Because of the
Angle addition postulate, you could use that. Or recognize that we've got a straight line here, right? And so angle ABC and CBE make a linear pair. So if ABC is 28, then this is going to be, what would that be, 152? Okay, to get that 180. Because of the angle addition postulate, we know that the sum of these two angles have to equal the whole thing, which is 180. Okay, the next one. We didn't get to this one in the blue class, but we can do it here. Our job is to solve for angle POR and ROQ. Okay, POR is this angle here. And ROQ is this angle here. So what relationship can we set up, or what equation can we set up that's going to allow us to solve for x so that we can plug that value in and get the values of the angles that we need? Audrey?
You could, since it's like a straight line, they're all going to add up to 180.
Yeah. Do we have a linear pair here? No. A linear pair is specifically two angles that add to 180, but we do have a straight line. And so these three angles, even though they're not a linear pair, will add up to 180 degrees. So our relationship is 5x plus 4 plus x minus 2 plus 3x plus 7 equals 180. All right? Those three angle measures, the sum of those three angle measures will add to be 180. Now we get to combine some like terms. That's always fun. We've got 5x is here, another x there, 3x is there. Total, that gives us, anybody? 9 x's. And then we have positive 4 as a constant, negative 2, and positive 7. Positive 4 minus 2 plus 7, we end up with, anybody? Positive 9. So we have 9x plus 9 equals 180. It is perfect, isn't it?
Oh, yeah.
How it all fits together, it's lovely. Anyway, subtract 9 from both sides. We get 9x equals 171. Divide both sides by 9 to get x by itself. What could possibly be more interesting than this, what I'm doing right here, right now? Really? Oh, that is pretty interesting, actually. Don't touch yourself, yeah. And so x equals 19. Which again is only half of the answer here because we're looking for angle POR. Okay. If it were me personally, I would just find each of the three angles here and then combine what I have to, because POR is actually, it's two of the three angles together. So if x is 19, 5 times 19 plus 4 gives us 99 degrees here. SOR, x minus 2, 19 minus 2, would be 17 degrees here. And then ROQ, 3 times 19 plus 7, 64 degrees there. And it's worth it to take the 7 seconds to add 99, 17, and 64 and make sure you get 180, right? Because if you don't, that means you don't have the right value for x, which means you're not going to get the correct answer in the end. Geometry is nice because it constantly gives you opportunities to check your answer. But anyway, looking for POR. POR would be angle addition postulate, POS and SOR together, these two. So that gives us 116 degrees. And then ROQ is just the third one there. That gives us 64 degrees. All right, message received. Let's wrap up. Okay, so your homework, in addition to, we went through this in private. So your homework then from your textbook is on. Well, we would have done it together, but then you started yawning, so I figured you want to go home. No, you'd have had homework anyway. On page 29. On page 29, I would like you to do 22 through 26. Page 29, 22 through 26, and then 29 through 38. 29 through 38. It's not that bad. It's like 13 questions. And you have till Friday to do it. So
We can just do it tomorrow.
you can do tomorrow. But you have con due tomorrow night, so balance. Balancing act. Thank you for your attention. It is exactly 2:45, so we are done for the day. That is how you math.
Don't forget to like and subscribe.